Hey everyone, this is problem statement number 852 of Leetcode peak index in a mountain array, and I'm using C++ to solve it. Problem statement says there is an array ARR, a mountain, if the following properties hold. So if there is a peak in the array ARR, then the properties it will be having are as follows. It's saying ARR dot length is greater than or equal to 3. So that's one of the conditions. There exists some I with 0 which is less than I, and I is less than ARR dot length minus 1. This is all the stuff that you can read basically. So imagine a mountain basically, and the left side and the right side and the peak is having a relationship. So peak can be taken as, if let's say the peak is ARR of mid, then that ARR of mid is greater than both of its adjacent sides, right? So it's greater than the right side and it's also greater than the left side, right? So if so we can write it as follows. If ARR of mid is greater than the left part and greater than right part, then we can write it as ARR of sorry ARR of mid plus 1 and ARR of mid minus 1. This is the basic condition which needs to be follows. All right. Okay. So we need the problem statement says that ARR is guaranteed to be a mountain array, and these are the sample inputs. You can check all this. So you must solve it in O of log n. It says time complexity. So O of log n simply means it's a binary search problem. Binary search means divide and conquer technique, right? So we simply define our start and end of the array. S is equals to 0, which is my start, and E is equals to ARR dot size minus 1 to calculate the end of the array, which is the, some people might may call it as start and or high low as well. So that's the same thing. Then a loop is initiated and I'm going S less than E because I to don't want for if we write S less than equals to E, then it will give us a time limit exceeded error, which we don't want. So simply S less than E, and then we calculate our mid, which is S plus E minus S by 2 to avoid any overflow. And then we are just comparing our mid with our mid plus 1 element, right? So yeah, so if our mid is less than our mid plus 1, then it simply means that there is a possibility that we may find our peak element on the right side, correct? So we move our SN, that's our start, to the right side. So we move our S to mid plus 1, all right? And then the only, either there are only two sides from the peak, the right and the left, right? So we have checked on the right right side, on the start of the, sorry, on the left side, on the start, on the start side, right? Then the only part remains is the right side, which is the end side. So if you notice the array, if we have a mountain with all the values of array, then the values will start increasing till the peak, and then they'll start decreasing. So an increasing slope and then a decreasing slope, correct? Then we move our S to our righter side. But if the other if we have done this, then the only other remaining scenario is, then we also need to check for the right side, correct? So if that is the scenario, then we are writing it as equals to mid. Why are we doing that? Because the mid could be a potential, right? So for the left to right side, there is a possibility. So as I said, so from left to right the values are increasing, right? It's in the increasing order. But when we are going from right to left, it's a different case, correct? So this is why I'm writing e is equals to mid. So there is a possibility that our mid, which is our mid, uh, equals to E, is also a peak element. So we don't want to negate that. If we do that, then our we can, if we write E equals to mid minus one, then we move further of the mid, right? So we move further left, and which we don't want. We want to include that element of the array as well. And the time when all the iterations have happened in the loop, then at some point we may come at s equals to e, where both the elements are together, both the pointers are together, then we simply return s. That's it. Let's try submitting it once again. Just a disclaimer, I have banged my head for very long for this problem, and I finally got through it. So I've already submitted it, but let's submit it once more. Yep. So as you can see, I've got multiple submissions and experimentations. I hope this has helped. Ask me if you have any doubts. I'll try my best to help you out with those. Thank you for watching. Have a good one.